All right, y'all, so we're back. We're going to come into chapter 2 now. Previous stuff was probably like the only thing you really need to know from chapter 1 is just some scientific notation. We're really going to dig into these measurements. So this is the textbook for my Chem 19 class. If you are Chem 2A, Pasadena has their own little textbook. And I think they have some newer version of this, but I have this one. It's an older version. So, you know, whatever you need for the Chem 2A class. Chem 19, you do have to have the master in chemistry. So you can either have a textbook or not, but you got to have that online part. So we're in chapter 2 here. It's the same chapter 2 for each class. I will make different videos once we need to kind of branch apart, but for the first few chapters, we're all in this together. So units of measurement. So we're going to be using the metric system in chemistry. So we're going to forget about them inches and then miles. We're going to be using kilometers and centimeters and meters. And we're going to be using Celsius, not Fahrenheit. If you want to try to kind of get yourself in the mind of a scientist, you can change your weather app over to Celsius and see how that like causes you just to like think a little bit more about something every day. So it's good. We're going to use kilograms instead of pounds. If you're going into healthcare, which I know a lot of you are, you probably already know this, but a lot of the American hospitals and things are moving over to kilos because there are medications and things dosed in other countries for kilogram of patient, and people have been misdosing patients when they do that conversion from kilos to pounds. So I know at my vet's office, they're even measuring our animals in kilograms now instead of pounds. And I get measured at Kaiser in kilograms now instead of pounds. And you really don't want to be that healthcare provider when your patient asks you, oh, what is that in pounds? And you have to like pull out a like app or something to do that. Like you want to be able to kind of quickly probably tell them around what it is. And so knowing a conversion from kilos to pounds is going to be really helpful for y'all in healthcare for sure. So some of these you're going to be memorizing, or you have already memorized some of these SI prefixes, but you need to know the base units. So we're going to be using the metric system here, and SI is an international system. So the international system are these units, but we're going to be using these units more in just lab and stuff. When you're talking to other scientists, you will be using this. And so for chemistry, like we will not be using kilograms because I'm not measuring kilograms of stuff. But if you go into industry and you are literally making kilograms worth of bleach or something, then you may use kilograms. Volume is typically going to be in liters, like measured in a graduated cylinder, or you can probably look at your measuring cup and see either ounces, or you can also see milliliters, right? So challenge yourself to look for metric system in everyday life. Instead of using the inch side, use the centimeter side of a ruler, and just kind of immerse yourself in that environment, because we don't have in-person labs, so you can kind of turn your kitchen into a lab. Instead of looking at tablespoons, look up a quick conversion for how many milliliters is in a tablespoon or something. Expose yourself to more units, because it's going to help you just get an idea of like what that means. Because if I ask you in the lab to give me 100 milliliters of something, and that's about X tablespoons, you could probably kind of eyeball a relative amount, right? Depending on how much you cook and measure things out in the kitchen. But I highly recommend just kind of poking around in your kitchen and looking for other units that you're not used to. So length is measured in meters. We're probably going to be measuring things honestly in centimeters, but meters is the base unit here. Be careful with using yardsticks and things, because a lot of them are in inches. So if you're measuring something at home and you want to like explore using the metric system, make sure you use the centimeter side of the ruler, because a lot of times there's also an inches side. One conversion that you probably want to learn is this one. I honestly use this conversion if I'm buying some stuff from IKEA, because they give measurements in a metric system. And if I need to know inches or feet of my like room and I need to measure something, they don't give you inches and stuff. They'll give you like meters and centimeters. Or if you're ordering something from Amazon for another country, they don't, they're not going to give you the English system. So that's honestly one that I use a lot. It's 2.54 centimeters is equal to an inch. Next up is volume. Liters are the metric system, or you can have any cubic feet. So volume is either a liter or some kind of version of a liter, like milliliter, nanoliter, or some kind of length cubed. So volume is space, right? So when you think about it, for example, the volume of a cube, there's my cube here, is length times width times height, which would be like centimeters cubed, for example. Or I could actually measure it in liters if I'm using a liquid. So if you're kind of using a liquid, you probably want to measure it in liters or milliliters. But if you're measuring the volume of like a solid object, we might want to use length of that object to help me with that. And then, you know, I don't necessarily say that you should memorize any of these like quarts or anything like that, but because it's on your back of your periodic table, but you will learn milli as a prefix. We'll be measuring mostly in mass, mostly in grams for mass, but you'll be measuring your patients, of course, in kilograms. And so knowing the conversion here is really helpful. 1 kilo is 2.20 pounds. It's actually 2.205. If you want to get extra technical, you can go for it. But 2.20, just 2.2, or just multiply by 2 and then multiply the number by 2 and then multiply that number by 0.2 and add them together. That's a really good way to kind of estimate it. If you're trying to do it in your head for your patient who's asking a lot of questions like I do when I go to the doctor. It's also helpful if you're kind of weighing stuff out in the kitchen and you need a pound of something, it's 454 grams. And so, you know, if you're, depending on what kind of cookbooks you're using, if you're using a cookbook from a different country, you know, you may be asked to measure something in grams instead of pounds. Temperature is important that the SI unit is in Kelvin. We will be using Kelvin actually in calculations, but we measure temperature in science in Celsius. So again, change that weather app over to Celsius and see how you do for a couple days. Celsius is really great because water freezes at 0 and boils at 100. So Celsius is based around the properties of water, which is used a lot in science. And so we kind of just use Celsius for that reason. And then Kelvin, 0 is the lowest possible temperature we can go, which is called absolute 0. And it's where all particles stop movement. So we're never really working that. I mean, you have to have special conditions to work in absolute 0. So Kelvin is an absolute scale. There's no negative. Everybody knows about time. Okay, seconds, minutes, days, hours. Hopefully you know all those conversions already. We're going to talk about significant figures, and I have this little map here of the lower 48 states, and I am going to show you a couple of rules here with this map. So, first rule, I'm going to zoom in down here, is the Pacific rule. So here's the Pacific Ocean. Okay, it's on the left side where we are. Whoop, there we are. Somewhere right in here, right? Yeah, it's us. We're on the Pacific Ocean. It's probably too far south. It's fine. And so the Pacific rule says if a decimal is present, start at Pacific which is the left side of the number. So like on the left of the US, if you're looking at a map, the Pacific is the left side of the number. You're gonna move to the right, like a cross-country trip. You're gonna hit your first non-zero number. You're gonna count it, and you're gonna count every number after. Count it, and every number after. And I'm gonna copy this because I'm gonna use it on the other side. Oops. Okay, so what are significant figures? They are, you ever do math and then your calculator gives you like all these numbers and you don't know how many to put in the answer. The answer is always significant figures. It's the precision of your measurements. And so we have to be able to look at a set of numbers and tell how many of those digits are actually precise, because your calculator is giving you all these numbers, but when you measure something, there's a finite number of digits you can have in that measurement for that measurement to be honest, right? So that we're not making up information, we're not fabricating data in science. And so this is going to be, how do you tell how many significant numbers are in a number? And then we're going to talk about how do you measure correctly and how do you do math with these significant values. So talking about the Pacific Ocean here, let's look at an example. So looking at this example here, this is our example of Pacific because the decimal is present. So what we're going to do is we're going to take our number, and we're going to start on the left side of the number. So start at on Pacific because the decimal is present. And now we're going to move to the right. So we're going to move right. What's our first non-zero number that we get to? 2. So we're going to count this number, and then we count every number after. So how many significant numbers are there in this number? There were 3. 3 SF, 3 significant figures here. So that means that this 0 is significant. And what that means is the person that measured this number is telling me, I measured and I think that there's a 0 here. And I'm guessing this 0. The last number is usually a guessed number, but it's like, okay, I know that there's a 2 in this place and there's a 5 in this place, and I'm pretty sure there's a 0 in this place, but I can't guess. I only get one number where I get to guess. I can't be like, I think there's a 0 and then I think there's another 0. Like when you're reading a ruler, you can say, I think it's in between these two numbers, right? So I'll say like 0.5. That's what I'm talking about. You can guess. So we're guessing the 0, but we definitely know the 5 and we definitely know the 2 here. So we get one guess number and that's the end. So this person is telling me they know these 3 digits and they think this last one is significant. So those are your 3 significant figures here. So why don't you try this one? How many significant figures for this one? Pause and go for it. So this decimal is present. So this is a Pacific. So we're going to start on the left side and move our way over. My first non-zero is actually the 7. So I'm going to start counting and I'm not going to stop. So there are 5 significant figures here. No? Okay. Let's go to the other side. The Atlantic, where I'm from, Atlanta. There he is. Right there. Paste. Whoop. Do not want to paste the whole image. Just want to paste the text. This little dude's head kind of get in my way. It's pretty cute though. Okay, I'll just change my. Okay, so we have the Atlantic Ocean over here. So this is for a decimal that is absent. So we're going to start at Atlantic and we're going to move to the left across the country. And then same rules apply. Get to your first non-zero, count everything after. Let's try it. Here we go. So I have no decimal. Decimal's absent. So I'm going to start absent decimal. Means Atlantic. So we're going to start on the left side of the number, work our way this way. My first non-zero is 2. And then keep going to the left. So this is 3 significant figures. So here's a hint. All sandwiches are significant, y'all. All sandwiches are significant. And this means that all zeros that are in between 2 numbers, so for example, that's a sandwiched 0. So a sandwiched 0 are significant. So if a non-zero number is always significant, so a non-zero number is always significant. And then a zero to the sandwich is always significant. So it's really all the zeros at the beginning and the end that you really need to be like worried about. And then you can use Atlantic Pacific rule to find that. So then we need to think about rounding. Rounding is really important here because, again, you know, you're doing the calculations, you get this long number in a calculator. Well, how do you know like where to stop, how to round? We're going to round these to 3 significant figures or sig figs. So what I like to do is I like to box the most important numbers for the value. So what are the most important numbers to maintain the value of this? Well, it's going to be the biggest numbers and the numbers in the biggest places. So my tens place, my ones place, those are the most important to keep the value the same. I don't want my answer to be not very close to 35.78. I want my answer to be pretty close to 35.78. So when we're rounding for sig figs, check yourself, because if you tell me that, oh, this 35.78 turns into 3.5, we can't change the number that much. So I'm going to put a box around the 3, because they asked me for 3. The 3 digits I think are the most important for the value. And then I'm going to look to the outside of that box. And we only look at one number to the outside. So I'm going to look at this 8. If it is 5 or greater, we round the next number up 1. So I'm going to round this to 35.8. And I'm leaving it alone. Isn't 35.8 close to 35.78? 2, 3? Yes. And it has 3 significant figures, right? Okay. So why don't you try the next 2? So for this one, I hope you did not circle these zeros at the front. They're not significant because my Pacific rule applies here. I'm starting from the left and working my way to the right. That 2 is our first significant digit. So I'm going to box these 3 numbers. The number to the right of the box, only one number to the right of the box, don't even look at that 7, is lower than 5, so I'm not going to round this up. But I cannot just leave these zeros off, because these zeros tell me how small or how big this number is. So I have to include these zeros at the beginning because they're placeholders. They're telling me, oh, no, not a 2, not a 2 here, not a 2 here, not a 2 here. There's where the 2 comes in. So to make sure we keep it this way. You can also put it in scientific notation if you're a little confused about how to change your sig fig. So how would I put this in scientific notation? 2.62 times 10 to the negative 3, because it's a small number. Scientific notation is pretty easy for sig figs. Anything before the times 10 is significant because of the decimal rule, the Pacific rule. And let's do this last one. So if I want 3 sig figs, I'm going to put my 3 numbers in a box. And I'm going to say equals 3.83 because I have a 6 on the outside of the box. But you can't forget to include the rest of your number. You can't just say, so not equal to 3.83. It's not the same, because if I owed you 3.83 times 10 to the 3, I owed you $3,000. If I gave you $3 because sig figs, we're not square, right? So make sure your number actually is very similar to the original number as far as the value goes. Okay, so now I'm going to show you how to do significant figures rules. So we're going to start with multiplication and division. So the multiplication rule . Don't leave myself any space to give you the rule. Let's do this. Add a page here. Okay, multiplication and division rule. Is pretty simple. The lowest number of sig figs in your calculation is equal to the number of sig figs in your answer. You're only as precise as your least precise input. So let's do a little math here. So go ahead and calculate these out. All right, so we have our answers here. So now we need to round for sig figs. So the sig fig rule says that the lowest number of sig figs in your math is the answer number of sig figs. So looking at our sig figs here, we have 3 and 2, because that 0 in the beginning is not going to count. And so how many sig figs should my answer have? Should have 2. So let me do my little box for rounding. So that's going to equal to approximately 21 because there's a 0 on the outside of that box. Ignore that 1 6 down there. We only look at the one number to the right of the last place of significance. So let's look at B. Now for B, if you didn't get this answer 32, it's probably because you entered this into your calculator incorrectly. So if you're using ClassCalc, enter it in exactly like it is, put parentheses around the top 2 numbers, and then press divide, and it will give you a bottom section, and you just type in whatever's in the bottom. So for ClassCalc, put parentheses around the top, then press divide. It gives you a bottom section. Go for it. If you're not using ClassCalc though, you need to make sure that you're dividing both of those bottom numbers. The best way I can tell you to use a normal scientific calculator is this. So enter it in. Probably should change my color. Enter it in as 2.075 times 0.585 divided by 8.42 divided by 0.0045, because that's what that really means. When a number's in the bottom, it means it's getting divided. So unless you want to put the bottom in parentheses, so if you really want to multiply these 2 bottom numbers, you have to divide and then you have to open parentheses. And then you can multiply them together. But I think that that's extra work. So just any number that's in the bottom, just put a division sign in front of it and your calculator will do it right the first time. So looking at our sig figs now, going back to this, I have 4, 3, 3, and 2. So I need 2. Again, we have a 0. So I'm looking at 32 as my answer for this one. So definitely text me as you're watching this. If you've got questions, just send me a quick little picture, screenshot, whatever question you're on. If you're not sure what's going on, just send me a text message and I can help clear it up for you. Just like I could answer questions for you if you were in class. It's just that you're going through this at a different time than someone else. That's totally fine. Y'all text me throughout the day and evening and I'll get back to you when I can. So this one, 25 over 5, oh, that's 5, right? But my sig figs are not done here. My lowest number of sig figs is 3. So how do I remedy this? I add some zeros, y'all. Make it work to represent what you really need. If you need to add zeros at the end, add zeros. Just don't make it 500 because that's not 5. But if you need to add some zeros, you know, at 0.00, that's fine. Go for it. So let's look at how we deal with addition and subtraction. So I'll put the rule up here with the other one. I'm going to keep everything straight. So here's our multiplication and division rule. Then we have our addition and subtraction rule. You get one more sig fig rule at the end. You'll think you'll forget that you have another sig fig rule, but we're going to get one more at the end of the class. So you'll get another one. And don't worry, there's more than just 2 sig fig rules. I know you're like really excited to learn about all the significant figure rules. Addition and subtraction is a little bit harder to do because you have to visualize it and you have to forget totally about the first rule. They're totally separate. And if you're doing multiple step problems where you have addition and subtraction, multiplication and division, then you're going to have some troubles there. So make sure that you write this out every step. And then I like to put a box around my sig figs from each step and keep the other numbers on the outside. And I'll kind of take you through an example of this. So addition subtraction rule says the number of decimal places. So the number of significant decimal places. Lowest number. I can write. Lowest number of decimal places in calculation equals number of decimal places in answer. So I do not care how many sig figs there are. I care about how many decimal places are there. So like, does this go all the way to the hundredths place or does this stop at the ones place? Because the lowest number of where it stops is going to be where I have to cut it off. So what I want us to do is to not really think about our numbers like this. I want you to line them up old school style. So I'm going to line this up with my decimals all lined up. And it's really important to line the decimals up here so that everybody is all in their correct place. We're going to go ahead and just do the math. And then we're going to cut it at the least precise number. So which place is the least precise? Right, it's the ones place. So we have to cut it here. So to the left of the ones place, all those numbers get to stay. To the right is a 2, so I'm not going to round it up. So my answer here is 151 milliliters. Do the next one on your own. All right, hopefully you've done that. Pause really quick. Done this number. I'm just going to go ahead and enter this right here. Make it a little easier for myself. Do your math out. We get 138.427. Where are we going to cut it? Right here. So you can't really, like, I don't know what these spaces are, so I can't really record that this 7 here. Like, I don't really know if that's a 7 because they didn't tell me what goes here in this place. Could it be a 0? It's a 7. If it's a 9, no, it's not a 7. That changes everything. So, you know, we don't really know this level. The last number we're able to guess was the 2 of this number as far as like we were measuring in the lab or something. And so you have to make sure that you're not writing more than you know in your answer. So my answer here is actually going to have 5 sig figs. And we're going to round that last 3 up. We got a unit there of grams. Okay. So some numbers are exact and they have infinite sig figs. So pretty much anything on the back of your periodic table, I want you to consider infinite. Anything on the front of your periodic table, like those masses of those elements, consider infinite. And then anytime we're counting a full number like 8 donuts, 2 baseballs, 30 people, that's infinite. It's exact. Now, when I say exact, I mean like I want you to think 5.0000 to infinity capsules. Okay, and so thinking about your sig figs there, it's just a counting number, so it's infinite sig figs. And then if it's in a definition, so like the definition of a liter is equal to 1,000 milliliters. So don't count sig figs here. Any sort of SI conversions, don't count sig figs. And pretty much any within the same system, don't count it. But if it's with a different system, so like if you're going from miles to kilometers, that's measured because they're not in the same system, so they don't define each other. So you do have to count sig figs for that. There's one exception to that rule, which is the centimeters to inches rule. But most of the time, conversion factors I'm going to give y'all, don't count them for sig figs. So they're not going to make your sig figs 1 to use this conversion. It's not going to make your sig figs 1. So just kind of ignore this as a sig fig issue at all. So when we're measuring things, you will be given images like this and asked to measure them like you were in the real lab. You always record numbers to 1 decimal place after they're marked. So here in A, the marking is every 1 centimeter. So I'm marked to 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. So if it's marked to the ones place, what place is after the ones place? We read to the 10th place. So we get to say 4.5 centimeters. This one is marked to what place? Every single little marking is 0.1. So this one is marked to the 10th place. So what comes after the 10th place? I get to read it to the 100th place. That's why I get to say 4.55, because I think that it's, I think it's in between 4.5 and 4.6. So I get to say 4.55, I get to guess. And this one's in between 4 and 5, so I get to say 4.5, and maybe my lab partner thinks it's 4.4. That last number we can argue about. That's the number you have to stop at. When you can argue that number with somebody else, you're done. You pick a number there and you can't say anything else. I can't say, well, that's 4.50 because I don't have anywhere to know where the 0.5 is. I'm guessing that last number. So we've only guessed once. And then here, this one is also marked to the ones place, but it's a common mistake for students because they just want to put 3. But this marked to the 3 to the ones place, so we have to read it to the tens place. So if you think it's right on the 3, you gotta say 3 point what? So we gotta say 3.0. So make sure that you're reading those correctly. Oops. All right, sorry about that. So we're gonna now I'm gonna get you kind of set up for your first memory quiz, and these are your SI prefixes that you need to know. They're on the memory list handout for you, memorization list handout. You don't need to know all of them, just a few of them. I think it's easier to remember like the kilo means 10 to the 3. And so when you're writing this out, if you just memorize kilo means 10 to the 3, it's easy to put it into a conversion factor. So I'll show you how to do that in the next segment. But if you're just memorizing mega is 10 to the 6, giga is 10 to the 9, centi is 10 to the -2. So I think that this column and this column is really helpful. Now, if you already have them memorized in a certain way, like, oh, I know 100 centi is one thing, that's fine as well. But I think that's really helpful for students to kind of know what the actual prefix means. And that's how I'm going to test it on the memory quiz. So I'll give you 10 to the -1 and you tell me D for deci. I give you C for centi, you write 10 to the -2. That's what it means. A note about micro. You definitely may have patients who are taking microgram doses of medications or microliter doses of medications, depending on like whatever medication it's being given. The abbreviation for micro, because if you're thinking about reading someone's handwriting, how can I tell milli and micro apart? And you can overdose a patient if you think it's milli, or underdose if it's not, right? So we use MC because this fancy letter called mu, it's a Greek mu, is sometimes misread. So you can write MC if you want to, or you can try the mu, or if you're typing it into Google Drive, you can use the symbol if you want to, or you can use MC for micro.